Welcome to Copilot Podcasts. The universe began with uranium, not hydrogen, not helium, uranium. And if that sentence just broke something in your brain, good, because that is exactly the kind of rupture we are here to explore today. The James Webb Space Telescope has been sending back images of galaxies at redshifts beyond 10, galaxies that are chemically mature, metal-rich, and structurally complex at a point in cosmic history where the standard model says there should be almost nothing but pristine hydrogen gas. Today, we are diving into KT Cosmology, a framework built by Abdon E.C. Bishop that proposes to explain all of this. Specifically, you are going to understand what the curvature torsion rails actually are, why the universe might not be expanding the way you think it is, and how JWST's most shocking findings become completely expected once you swap out the old model. I have got someone here who has gone deep into all 4 chapters of this framework, and I want to start with the most disorienting thing I read, the claim that Einstein's unification problem is already solved. Walk me into that.
So the starting point of KT cosmology is a diagnosis. The ACDM model, that is the standard lambda cold dark matter model, is described in the framework as collapsing under the weight of its own contradictions. You have the Hubble tension, you have DSI's data on evolving dark energy, you have JWST's early galaxies, and you have statistical anomalies in large-scale structure. And the argument is that these cracks are not random, they are directional. They point toward a deeper geometric structure that scalar-based cosmology simply cannot see.
Okay, so directional cracks. What does that mean exactly? It means the failures of ACDM are not just measurement errors or missing parameters, they are symptoms of a wrong geometric assumption. And the replacement that KT cosmology offers is this. Instead of a cosmological constant lambda, you have a curvature torsion dual field. The universe is generated by the product of 2 orthogonal eigenvectors, curvature, which is labeled tau, and torsion, which is labeled kappa. And the core identity is universe of t equals k of t times tau of t. That product is not metaphorical, it is the generative engine of spacetime.
So 2 rails, and they are orthogonal, meaning they are at right angles to each other geometrically.
Exactly. And the decomposition is very specific. Torsion acts tangentially, it modifies angular structure, circulation, and twist. Curvature acts radially, it modifies metric expansion, geodesic separation, and radial displacement. So the universe evolves along 2 orthogonal rails, tangential torsion and radial curvature. And here is where the Einstein connection comes in. The framework assigns general relativity to the curvature rail and quantum mechanics to the torsion rail. GR lives on what are called sphere-class manifolds with Euler characteristic chi equals 2. QM lives on torus-class manifolds with Euler characteristic chi equals 0.
Wait, so GR and QM are not competing theories that need to be merged? They are already 2 separate rails of the same manifold?
That is the claim, yes. And the framework is very direct about why every previous unification attempt failed. String theory, loop quantum gravity, Einstein's own attempts to geometrize electromagnetism, all of them tried to force GR and QM into a single mathematical domain. KT cosmology says that was the wrong move. You do not merge them. You recognize that they are orthogonal components of a single geometric engine, and their interaction is multiplicative, not reductive.
That is a genuinely bold claim. And I want to make sure listeners are tracking this. So the Euler filter, which the framework calls V equals the set containing 2 and 0, that is what enforces which rail each theory lives on?
Right. The Euler filter restricts admissible geometric cells to manifolds with Euler characteristic chi equals 2 or chi equals 0. Chi equals 2 is assigned to curvature domain cells, sphere class, simply connected, radial, energy conserving. Chi equals 0 is assigned to torsion domain cells, torus class, looped, angular, momentum conserving. And this is not decorative. The framework describes it as the backbone of the unification. Energy conservation becomes a curvature sphere invariant. Momentum conservation becomes a torsion torus invariant.
So conservation laws are not just algebraic rules, they are topologically encoded into the geometry of the manifold.
Exactly. And there are 2 specific conservation laws that govern the rails. On the curvature rail, radial energy conservation holds, delta J equals 0. Curvature cannot create or destroy energy. On the torsion rail, tangential action conservation holds, delta J times S equals 0. Torsion cannot create or destroy action. And crucially, these rails are algebraically closed. Energy cannot leak into torsion, and momentum cannot leak into curvature.
But something has to connect them, right? Otherwise, you just have 2 completely separate systems.
Yes, and that is what the framework calls the bridge condition. The only legal cross-rail interaction occurs when torsion violates its own action conservation, when delta J times S is not equal to 0. When that happens, the torsion rail has lost or gained action, and geometry requires that imbalance to be compensated by a radial projection into the curvature rail. And that projection is what produces dark energy-like behavior, but defined purely as a geometric correction term, not as a mysterious constant or exotic field.
So dark energy is not a thing, it is a geometric consequence of torsion losing balance.
In this framework, yes. The operator A of t equals negative pi of dk is described as the dark energy-like operator, and it evolves naturally. The framework explicitly says this explains DCI's weakening dark energy, JWST's early galaxies, and the Hubble tension, all from one geometric mechanism.
Okay, I want to take a slight detour here because there is something in the framework that I found genuinely fascinating and a little unexpected, the geological framing. KT cosmology literally maps cosmic history like rock strata. There is a hypereon, a condensate era, a neutral period, a curvature epoch. It is like reading the universe the way a geologist reads a cliff face.
And that framing is not just aesthetic, it is functional. The KT Cosmic Geologic Extension Map described in Chapter 2 has 4 stratified cosmic layers, each color-coded and each corresponding to a specific curvature torsion regime. The lowest layer, the hypereon stratum, is the torsion-dominant basement of the universe. Above it is the rogue condensate belt, then the boundary neutral epoch representing the present universe, and then the future curvature epoch at the cosmic edge. The scale bar on that map spans 0 to 10 billion light-years.
That is a wild way to visualize cosmic time. But let's get into the meat of what happens in those epochs, because this is where it gets really strange. Start with the early universe.
So the early universe in KT cosmology is defined by torsion dominance. The inequality is that the rate of change of kappa over time exceeds the rate of change of tau over time. Torsion grows faster than curvature, and the tangent direction, which is the partial derivative of kappa with respect to tau, rises to values far exceeding unity. The framework calls this the primordial blue-gold era.
And what does that extreme torsion dominance actually do physically?
It produces what the framework calls geometric heating. And this is a crucial distinction. Temperature in this regime is not a thermodynamic variable. It is a geometric consequence of torsion amplification. The effective temperature scales with the tangent direction, so as torsion outruns curvature, the manifold enters extreme Kelvin regimes without requiring particle-based fusion, collisions, or any thermodynamic processes. The framework describes it as a geometric blowtorch, a focused curvature torsion compression.
So heat without thermodynamics. That is a sentence I did not expect to say today.
And the consequence of that geometric heating is what the framework calls Gibbs collapse. In standard nuclear physics, heavy elements require multiple fusion steps, neutron capture, slow R process pathways. All of that takes time and stellar environments. In KT geometry, those steps are bypassed entirely. When the tangent direction exceeds a critical threshold, the effective barrier height between low Z and high Z nuclear configurations collapses to an infinitesimal residue. And in the arithmetic substrate, infinitesimal barriers do not support exponential suppression. The tunneling rate saturates to order unity.
Meaning nuclei just jump directly into heavy element configurations, with probability of order 1 on the substrate timescale, yes. The framework defines hyperperiodic table elements as nucleonic configurations formed in regions where the torsion curvature tangent direction satisfies that critical condition, driving the substrate into a tunneling-dominated phase where classical nuclear barriers collapse. And these hyperelements include nuclei with Z greater than or equal to 92, uranium, thorium, primordial actinides, and what the framework calls super-heavy protoisotopes beyond the classical periodic table.
So uranium forms before stars exist, before stellar nucleosynthesis is even possible. That is the claim. And the framework is explicit that this is not a chemical accident, it is a geometric inevitability of the torsion curvature substrate. The hyperperiodic table is described as not an evolutionary endpoint, but an initial condition. The earliest galaxies inherit heavy elements directly from the substrate's geometric dynamics.
And this is where JWST comes crashing in, right? Because JWST has been finding exactly this, chemically mature galaxies at redshifts where they should not exist.
Chapter 3 of the framework is entirely dedicated to this reinterpretation. JWST has detected metal-enriched gas at Z greater than 7, dust reservoirs in chemically primitive galaxies, solid grains including iron, silicon carbide, and polycyclic aromatic hydrocarbons in early systems, and rapid chemical evolution that is inconsistent with slow stellar pathways. Under ACDM, these signatures require multiple generations of stars and supernovae. Under KT cosmology, they arise naturally from torsion-dominant tunneling in the early epoch.
And NASA's own reporting on JWST backs up the anomaly side of this. NASA described the galaxy MOM-Z14 as existing just 280 million years after the Big Bang, and noted there is a growing chasm between theory and observation related to the early universe. That is NASA's language, a growing chasm.
And the RxEve paper by A. Coley from Dalhousie University, published in late 2023, makes the same point from within the standard framework. Massive galaxies greater than 10 to the 10th solar masses at Z greater than 7 to 10, formed less than 700 million years after the Big Bang, do not have enough time to form within the standard cosmological model. That paper explicitly says these observations significantly challenge standard cosmology.
So the anomaly is not just KT cosmology saying ACDM is wrong, mainstream astrophysics papers are also saying something is broken.
Correct. And KT cosmology's response to that is not to patch the standard model, but to replace the geometric assumption underneath it. The key replacement is boundary-only expansion. ACDM assumes space expands uniformly everywhere. KT cosmology rejects that. The interior manifold does not expand. Cosmic growth occurs exclusively at the outer boundary, a finite closed horizon at approximately 13.8 billion light-years. The interior remains static. Wait, so the universe is not expanding like a balloon inflating from the inside. It is more like the surface area of a sphere growing while the interior stays fixed?
That is a reasonable geometric intuition for it, yes. And the consequence is significant. A static interior preserves density and enables rapid gravitational collapse. It eliminates the dilution effects inherent to ACDM, so early galaxies can form quickly and reach high masses without requiring extreme star formation efficiencies. JWST's detection of massive galaxies at high redshift is, in this framework, a natural consequence of boundary-only expansion, rather than an anomaly requiring exotic explanations.
And this also connects to the Hubble tension, right? That persistent discrepancy between local and cosmological measurements of the expansion rate.
Directly. The framework's explanation is geometric and clean. Local measurements probe the static interior. Cosmological measurements probe the expanding boundary. Of course they disagree, they are measuring different things. ACDM must introduce new physics or invoke systematic errors to explain the tension. KT cosmology resolves it through boundary geometry. The tension is not an anomaly, it is a signature of a dual-field universe.
That is actually a really elegant resolution if it holds up. Now, I want to get into the KT Rails diagram because that is the central visual anchor of the whole framework. Walk me through what it shows.
The KT Rails diagram plots the evolution of torsion K of T, curvature potential tau of T, and their product, the Gaussian curvature field C Gauss of T, equals K times tau, across cosmic time from 0 to 14 billion years. The horizontal axis is cosmic time, the vertical axis is the magnitude of the rails in torsion and curvature units, and the diagram is partitioned into 3 shaded regions corresponding to the 3 cosmological epochs.
So 3 epochs: early, middle, late.
The early epoch spans approximately 0 to 4.67 billion years. Torsion rises sharply while curvature remains small. This is the torsion-dominant tunneling zone marked in red on the diagram. Geometric compression overwhelms classical nuclear barriers. Gibbs collapse occurs. Hyperperiodic nuclei with Z greater than or equal to 92 form primordially. The anchor point labeled uranium-4. 54 marks the onset of this phase at T equals 0, the primordial hyperelement nucleation boundary.
And the placement at t equals 0 is a statement. The universe begins not with hydrogen simplicity, but with torsion-driven geometric complexity.
That is exactly how the framework phrases it. Then the middle epoch spans approximately 4.67 to 9.33 billion years. Torsion decreases while curvature increases, bringing the two rails into balance. The cyan-shaded region marks the curvature-dominant ejection zone, where tau of t exceeds kappa of t. In this regime, curvature extends centrifugal acceleration, enabling baryon cycling, mass redistribution, and the formation of toroidal heavy element rings around early black holes.
Toroidal rings around black holes? So the heavy elements that formed in the early epoch accumulate in these rings?
Yes. The framework describes a hierarchical process. In the torsion-dominant epoch, bosons establish the initial angular scaffold of the toroidal ring. Then neutrons enter the bosonic circulation rail under geometric heating, which suppresses beta decay channels. Then protons are drawn in, completing a three-layer structure of boson, neutron, proton, a metastable nuclear substrate. This substrate is the geometric precursor to hyperperiodic nuclei. When the tangent direction exceeds the tunneling threshold, the effective barrier height collapses and nucleonic configurations transition directly into high Z basins.
And then what happens to those rings in the middle epoch? The curvature vector activates and extends centrifugal acceleration radially outward from the outer edge of the toroidal ring. This destabilizes the ring and initiates mass shedding. The outer edge becomes a launch surface. Hyperperiodic nuclei experience inward gravitational pull, outward centrifugal acceleration, and outward curvature extended acceleration. The net force ejects heavy nuclei from the ring. Their trajectories are determined by their split velocity relative to the escape velocity. Some enter bound orbits, some are marginally bound, and some go completely unbound into interstellar or intergalactic space.
And the unbound ones become something really interesting. The framework calls them rogue planet mass condensates. Unbound hyperelements drift into the cosmic medium as gravitational seeds. Their extreme rest mass and torsion compression history give them disproportionately strong local gravitational fields. Over millions to trillions of years, these seeds accrete hydrogen, helium, dust, metals, ices, and dark matter streams. The result is the formation of rogue planet mass condensates in interstellar and intergalactic space. These bodies do not form in protoplanetary disks, they nucleate directly from curvature-driven accretion around hyperperiodic seeds.
So there are planet mass objects drifting through intergalactic space that formed not from a star system but from primordial uranium seeds. That is genuinely hard to wrap your head around.
And the magenta curve on the KT rails diagram, labeled the rogue geodesic, traces the trajectory of exactly these condensates through curvature-dominant flows. It is one of the 4 physical anchors on the diagram, and it represents a testable prediction of the framework.
Let's talk about those 4 anchors because they form what the framework calls the complete KT evolutionary chain.
The 4 anchors are uranium-4, 54 at T equals 0 in the early epoch, representing primordial hyperelement nucleation. Primordial rogue Earth at T equals 4.54 billion years at the torsion crest, representing the transition from torsion-dominant ignition to curvature structuring. Archean surface STP at T equals 9.26 billion years, placed vertically at kappa of 0 but horizontally within the middle epoch, indicating it inherits the vertical torsion signature of primordial nucleation. And BH at T equals 13.8 billion years, placed at C Gauss equals 0, the KT boundary neutral condition where curvature potential drains at the cosmic horizon.
So the chain is hyperelement nucleation, then rogue Earth crest, then Archean STP, then boundary neutral black hole. That is the full arc of cosmic evolution in 4 points.
And the framework describes this as the first instance in which the KT rails diagram is fully populated with all 4 cosmological markers in their correct geometric locations. It is presented as a complete KT evolutionary chain, a coherent narrative of cosmic evolution driven by the curvature torsion product.
Now the late epoch, that is where we are now, right? What does the framework say about the present universe?
The late epoch spans approximately 9.33 to 14 billion years. Both torsion and curvature potential drain towards 0. The purple shaded region on the diagram marks the NSP saddle layer neutralizer, where dual channel conservation holds, delta E mod 4 equals 0 and delta P mod 4 equals 0. This neutralization halts geometric heating, eliminates tunneling, and stabilizes the boundary. The interior manifold ceases expansion. Only the cosmic boundary expands.
And the NSP mod 4 conservation, that is the non-standard physics axiom. Can you unpack that briefly?
The NSP axiom formalizes the conservation of energy and momentum as a mod 4 neutrality condition. The framework states that both energy and momentum remain neutralized across the mod 4 cycle at every successor depth. The saddle point between logical succession and rational physical identification acts simultaneously as an equality operator and a division operator, enforcing mod 4 neutrality. The conservation law is described as geometric rather than thermodynamic. It arises from the entanglement between logical succession and rational physical identification.
So conservation laws are not imposed from outside, they emerge from the geometric structure of the manifold itself.
That is the meta-message of that section, yes.
And it connects back to the broader claim about Einstein's unification. The framework says the failure of GR times QM arises directly from the historical assumption that both rails must share a single geometric substrate. KT geometry resolves the conflict by separating the rails and unifying the invariants. The algebra is topologically constrained arithmetic, producing a unified manifold without renormalization or quantized gravity.
No renormalization.
That is a significant claim because renormalization is one of the most technically demanding parts of quantum field theory, the process of dealing with infinities that show up in calculations.
And the framework's position is that those infinities arise from the wrong geometric assumption, trying to force both rails into one domain, separate the rails, enforce the Euler filter, and the infinities do not appear because the conservation laws are topologically encoded rather than algebraically forced.
I want to bring in the Planck's constant connection here because that is a really specific claim, that Planck's constant provides the quantized coupling between the two rails.
Yes. The framework states that the curvature-torsion exchange is quantized through Planck's constant. Non-conservation of torsion domain action induces curvature projection, and the coupling is described as the first true coupling between GR and QM, geometric, quantized, and non-perturbative. It does not require renormalization, extra dimensions, or exotic fields. It is described as the natural bridge between curvature and torsion.
Okay, let's zoom out and think about what this all means for how we interpret future observations. The framework makes specific, testable predictions. What are the key ones?
Chapter 3 lays out 6 categories of predictions. First, widespread actinide signatures with Z greater than or equal to 92 in high redshift systems, early dust reservoirs containing hyperperiodic nuclei, and metal-enriched outflows at Z greater than 10 without prior stellar generations. JWST should continue to detect chemically mature galaxies at epochs where ACDM predicts pristine composition.
And that first prediction is already being partially confirmed by what JWST is finding.
The second prediction is abundant galaxies of 10 to the 9th to 10 to the 11th solar masses at Z greater than 12, early black hole seeds exceeding 10 to the 6th solar masses, and large-scale coherence in protostructures. These should appear earlier and more frequently than interior expansion models allow. Third, high-velocity enriched gas exceeding 100 km per second without supernova feedback, toroidal heavy element rings around early black holes, and curvature-sorted baryon flows in protogalactic environments.
That third one is interesting because JWST has already detected disturbed enriched gas at high redshift with velocities exceeding 100 km per second. The framework says that is curvature-driven ejection, not stellar feedback.
Correct. And the fourth prediction is uniformity and coherence in early cosmic structures, suppressed turbulence in high redshift environments, and quantized energy momentum transitions in boundary regions, all arising from the NSP saddle layer. Fifth, persistent Hubble tension due to interior boundary mismatch, with local measurements deviating from boundary expansion rates. And sixth, complete curvature potential drain at the present cosmic boundary, collapse of torsion gradients, and boundary-neutral stabilization consistent with observed cosmic acceleration.
So the framework is making predictions that future JWST, ALMA, and ELT observations could test. It is not just a reinterpretation of existing data, it is generating new expectations.
That is what distinguishes it as a scientific framework rather than just a philosophical reframing. And the torsion-based modified gravity space is actually active right now in mainstream physics. A 2026 RxEve paper by Sai Swagat Mishra on cosmological evolution in torsion-based modified gravity, specifically F of T and F of T, T theories, shows that torsion-based modifications can shift late-time expansion and matter clustering, alleviating the H0 and S8 tensions. That is independent work arriving at similar territory from a different direction. And there is a 2026 paper in Research in Astronomy and Astrophysics on cosmic dynamics in Einstein-Cartan theory, analyzing Hubble tension through curvature and linear torsion fields. So the curvature torsion space is genuinely being explored in peer-reviewed literature. Einstein-Cartan theory is actually the closest mainstream analog to what KT cosmology is doing. It introduces torsion into general relativity through spin as the corresponding entity. The 2026 paper found that parameter constraints in models incorporating torsion are more consistent with CMB data and favor a lower H0 value, which is relevant to the Hubble tension. KT cosmology goes further by making torsion a generative rail rather than a correction term, but the underlying intuition about torsion's role in resolving cosmological tensions is shared.
That is a really important distinction. KT cosmology is not operating in a vacuum. It is engaging with a live debate in theoretical physics about whether torsion is the missing ingredient in our cosmological models.
And the primordial heavy element side of the framework also has a mainstream parallel. A 2025 RxEve paper from researchers at TU Dresden, Deutsches Zentrum für Astrophysik, and the University of Wroclaw explored primordial black hole formation and heavy R process element synthesis from the cosmological QCD transition. They argue that quark-gluon plasma inhomogeneities could become gravitationally stabilized and enrich the cosmos locally with heavy R process elements already in the early universe. That is a different mechanism, but the conclusion, heavy elements forming primordially before stellar nucleosynthesis, is structurally similar to what KT cosmology predicts.
So multiple independent lines of research are pointing toward the same uncomfortable conclusion. The early universe was more chemically complex than we thought, and our standard model does not have a clean explanation for it.
And NASA's own language from the MOEM-Z14 Galaxy announcement captures this perfectly. They said, and I am quoting directly, with Webb, "We are able to see farther than humans ever have before, and it looks nothing like what we predicted," which is both challenging and exciting. That is the scientific establishment acknowledging the gap. KT cosmology is one proposed framework for closing it.
I want to come back to something that I think is the most counterintuitive implication of all of this, the direction of complexity. Everything we were taught about the universe is that it started simple and built up complexity over time. Hydrogen to helium, helium to carbon, carbon to iron, iron to uranium through supernovae. Complexity is an endpoint. But KT cosmology flips that.
Completely. The framework is explicit. The hyperperiodic table is not an evolutionary endpoint, but an initial condition. The earliest galaxies are not primitive. They are born from a substrate that has already undergone a phase of extreme torsion-driven nucleonic tunneling. The hyperelements are described as the fossils of that phase, the residues of a universe that began not with hydrogen simplicity, but with geometric complexity. And as the universe expands and tau begins to catch up with kappa, the tunneling phase ends, hyperelement formation shuts down, and the periodic table collapses from its hyperextended form to the familiar 118-element structure observed today.
So the universe simplified over time. We are living in a chemically impoverished era compared to the early cosmos.
In a sense, yes. The hyperelements decay, fragment, or become locked into early dust grains and protoplanetary structures. Their signatures remain faint but detectable, anomalous isotopic ratios, unexplained heavy element abundances, and early universe metallities that defy classical astrophysics. The framework says these are the clearest signatures that the KT manifold is not merely a mathematical construction, but the generative engine of cosmic structure.
And Earth's deepest crustal bedrock, the framework actually makes a claim about that too.
Yes. In the hyper-eon geologic legend in Chapter 2, the framework states that Earth's deepest crustal bedrock inherits hyperperiodic residues from the hyper-eon epoch, transported through early galaxy formation and KT curvature focusing. So the uranium in Earth's crust is not just a product of stellar nucleosynthesis. In this framework, it is a geometric fossil of the universe's torsion-dominant infancy.
That is a remarkable claim. And it is testable in principle. Anomalous isotopic ratios in deep crustal samples could be a signature.
The framework lists exactly that as a detectable signature, along with unexplained heavy element abundances and early universe metallities that defy classical astrophysics. These are the empirical handles that could distinguish KT cosmology from ACDM.
So when you step back from all of this, the curvature torsion rails, the hyperelements, the boundary-only expansion, the JWST reinterpretation, the evolutionary chain, what is the single most important thing to take away?
The framework's core argument is that the cosmology crisis is not a failure of observation, it is a failure of scalar-based assumptions. We have been trying to describe a geometric universe with scalar tools. The cosmological constant lambda is a scalar. Dark energy as a fixed background is a scalar. KT cosmology replaces all of that with a dual-field geometric structure where curvature and torsion are the universe's generative rails. Their product drives expansion, structure, and evolution, and all observables are projections or functions of that product. The universe is not expanding into emptiness, it is unfolding along orthogonal geometric rails encoded in KT.
And the practical implication for how we interpret future telescope data is significant. If KT cosmology is right, then every time JWST finds a chemically mature galaxy at a redshift where it should not exist, that is not an anomaly requiring a patch, it is a confirmation of a prediction.
Exactly. And the framework makes this point directly in Chapter 3. KT cosmology provides a unified geometric explanation for JWST's anomalous findings, demonstrating that early cosmic complexity arises naturally from curvature-torsion dynamics rather than extreme astrophysical efficiencies or dark energy-driven interior expansion. The anomalies are not bugs in the data, they are features of the geometry.
Here is what this really comes down to. We started this episode with a provocation. The universe began with uranium, and by the end of it, that sentence is not just a hook. It is a summary of a complete cosmological framework. KT cosmology is saying that the universe's chemical complexity, its structural maturity at high redshift, its persistent measurement tensions, and even the apparent incompatibility of general relativity and quantum mechanics, all of these trace back to one geometric fact. Spacetime is generated by the product of two orthogonal rails, curvature and torsion, and we have been trying to describe that product with a single scalar for 100 years.
And the framework closes with a statement that I think captures the stakes well. It says, the universe's operating system uses the curvature-torsion algebra K of t and tau of t to generate its Euler Gaussian prime zeta product field, and that field manifests as spacetime, expansion, and cosmic structure. Geometry is not the language we use to describe the universe. Geometry is what the universe is.
Geometry is what the universe is. That is a line worth sitting with. And here is the thing that I keep coming back to. If the KT rails evolutionary chain is right, if the sequence from hyperelement nucleation to rogue Earth to Archean STP to the boundary neutral horizon is the actual arc of cosmic history, then we are not at the beginning of complexity. We are at the tail end of a simplification process. The universe was more interesting at the start than it is now, and JWST is our first real window into just how interesting that start actually was. That is the thought I want to leave you with. Thanks for joining us on Copilot Podcasts, and the next time you hear that JWST found something that should not exist, you will know exactly what framework to reach for.